Hi folks, just going to run through the solutions to the quiz from the week of the 1st of June to the 7th of June. If we have a look at the first question here. Q is a point 3, negative 5, R is a point negative 7, 3. The gradient of the perpendicular bisector of QR is. With a question like this, I would always make a wee sketch. We've got Q, we've got R. A perpendicular bisector is a line that is perpendicular to it and it cuts it in half. So if we're looking for the gradient of this perpendicular bisector, first of all we're going to find the gradient of QR. And we'll just use the gradient formula there. So we're going to have 3 subtract negative 5 and negative 7 subtract 3, which gives us 8 over negative 10, which is negative 4/5. Because we're looking for the gradient of the perpendicular bisector, we use the fact that m1 times m2 equals negative 1 for perpendicular lines. So if we've got a gradient of negative 4/5, the quick way to work out the gradient of the line that's perpendicular is to flip it upside down and change the sign. So we had the last option here, which is 5/4. Okay, question 2. P has coordinates 4, negative 7. Q has coordinates negative 2, 5. What is the equation of the perpendicular bisector of PQ? So again, a sketch is quite useful here. We've got P and Q. Quick sketch of what a perpendicular bisector is. We know to find the equation of a straight line, we need the gradient of that line and we need a point that lies on the line. So the point that's going to lie on this line that we can use is the midpoint. We'll call that M. So if we work out the midpoint first by adding together the x coordinates and dividing by 2, and adding together the y coordinates and dividing by 2, we're going to have 2 over 2 here and negative 2 over 2, so we get a midpoint of 1, negative 1. So we've got a point that lies on the line now. Now we need the gradient of PQ so that we can find the gradient of the perpendicular bisector. So the gradient of PQ, just using the midpoint formula, we're going to have 5 subtract negative 7 and negative 2 subtract 4. So that's going to give us 12 over negative 6, which is negative 2. Using the fact that m1 times m2 equals negative 1 for perpendicular lines, we can see that the gradient is going to be positive 1/2. So at this point I like to write down all the things that I'm going to put into the formula. Y minus b equals m brackets x minus a. So a and b are the x and y coordinates of our point that lies on the line. So a is going to be 1 and b is going to be negative 1. And m is our gradient, which is 1/2. So if we write out the equation of our straight line and we substitute these things in, y minus by minus negative 1 would be y plus 1 equals m, which is 1/2 brackets x minus a, so it's x minus 1. At this stage I like to multiply through by the denominator in the fraction to get rid of the fraction. So we're going to have 2y plus 2 equals 1 times x, so it'll be x, and 1 times negative 1, which is negative 1. And then to get everything into the format of our question here with y's only on the left hand side, I'm going to subtract 2 from each side, so I'll get 2y equals x minus 3, which is our last option here. Okay, question 3. Find the points of intersection of the lines with equations 2x plus 3y equals 7 and 4x plus y equals negative 1. So I'm going to write these out. They're in a nice format for us to work with. It's just a case of using simultaneous equations. So I'm going to call this equation 1 and this equation 2. What I'm going to do is scale equation 1 so that we've got the same value of x's. So I'll multiply that by 2. So I've got 4x plus 6y equals 14, and that's my new equation 1. And equation 2 is 4x plus y equals negative 1. What I'm going to do here is equation 1 subtract equation 2. So 4x subtract 4x will cancel out. 6y subtract 1y will leave us with 5y. 14 subtract negative 1 leaves us with 15. 5y is equal to 15, so y must be equal to 3. And then I'm going to substitute that y equals 3 into one of my equations. I'll just go for equation 1 because it's all positive. So 2x plus 3y, so it's going to be 3 times 3 equals 7. So 2x plus 9 equals 7. If I subtract 9 from each side, I get 2x equals negative 2. Divide each side by 2, x equals negative 1. So what you have to do is you have to write that as a coordinate. Okay, so we've got negative 1, 3. On to question 4 now. And it's asking which point lies on the line y equals 2x minus 3. So we've got a couple of coordinates here and we've got options for both of them or neither of them. The easiest way to prove if a point lies on a line is to substitute in and see if the left hand side equals the right hand side. So we've got y equals 2x minus 3. If we start with a, which is 4, 5, and let's plug in our x value, y is equal to 2 times x, so it's going to be 2 times 4 minus 3, so that gives us 8 minus 3, which is 5. And we can see there that the left hand side is equal to the right hand side because we're expecting a y coordinate of 5. So A definitely lies on the line. We'll try it for the point with B. So this time we're expecting that y will come out as negative 7 if the point lies on the line. So y equals 2 times x, so it's going to be 2 times negative 2 and subtract 3. So that leaves us with negative 4, subtract 3, which is negative 7. Again, you can see that the left hand side is going to be equal to the right hand side if we've got y as negative 7. So B again lies on the line. So the answer is that both A and B lie on the line. Next question here. This is a graph of y equals 6 minus 2x. What are the coordinates of P? Now the first thing I notice is that P lies on the y-axis, and of course the x-coordinate of any point that lies on the y-axis is 0. So I'm going to substitute x equal to 0 into that equation. So we've got y equals 6 minus 2x. So y equals 6 minus 2 times 0. And we get y is equal to 6. So if x is 0 and y is 6, our answer is C. Alternatively, we could have taken the equation y equals 6 minus 2x and rearranged it into the form y equals mx plus c. So we get y equals negative 2x plus 6. C is the y-intercept. You can see that c is 6. We know in the y-intercept that the x-coordinate is 0, so that gives us a y-coordinate of 6. So you could have done it that way as well. Right. Oh, and that's us. Short quiz this week. Okay, hopefully that's helped. If you have any questions at all, then please get in touch with us.